SQL that got people hired 5 years ago isn't enough anymore. Even with the explosion of AI tools, Python libraries, and NoSQL options, SQL appears in over 70 to 80% of data related jobs. It is the foundational skill for data analysts, BI developers, data engineers, scientists, and even stakeholders who use SQL to retrieve the reports. Companies don't just want people who can run basic select statements. They need professionals who can write efficient, readable queries or large data sets. Let me walk you through the main SQL skills required in 2026 from basic to advanced. In this video, we won't just discuss about SQL but what after SQL to get into that dream data job? Let's begin. Let's start with the fundamentals. I know you want to take your SQL skills to advanced levels, but before you do, remember to master the basics. You should be able to use effectively select, where, order by, group by, and having. Use aggregate functions like sum, count, average, min, max. Data types, null handling, and date functions like, date trunc, extract, concat, etc. Basic data manipulation like string, update, delete, merge. Now, out of these, delete and merge are so much important. In the world of ETL, you have the concept of soft delete, where you don't remove the record completely but keep it in the system and mark it as delete with the help of some indicator or audit column. Merge is another very important operation because when you use ETL, you have some update, right? So, for the analytics purpose, you simply merge your current table with the incoming table and look for the updated records with the help of that audit column. Next, we have is the understanding of DDL versus DML versus DCL or DCL. Let me know in the comments if you already know these. Interviews often begin with simple filtering and aggregation problems to test your logical thinking and attention to edge cases like how are you handling the null values. Their all-time favorite is of course difference between where and having. Next, let's see the core skills. The core skills are the first step towards applying the SQL to the real world problems. Yes, I guess you guessed it right. These are querying multiple tables through joins. Let's say your manager or your client comes to you and asks for the last quarter's sale for a particular region for a particular product. Now you have different tables, orders table, customers table, which would mostly have the region, products table to get the product details and the category, and of course pricing. And there could be one region table, which would mostly be static. Now you have four different tables where you have the relevant data. How do you get the required data? Well, of course, you join them, you group them, and then you aggregate on them. To have a very concrete core SQL skills, you should know what inner, left, right, full outer joins are and where to use them effectively. There are cases when you might need to join same table with itself. A simple example could be an employee table and you want to display the employees and their managers. Since managers are also employees, their data is also in the same table. So, in this case, you might have to join the employees table with itself. But you might choose some alias like M when you're referring the table to get the manager's data. Well, this brings me to the next point, understanding the table relationships, which is the data modeling. You need to join two tables on a common key. This common key might not be the same name, and sometimes even the structure might be different because the source systems are different. For example, sales data might come from POS, which is the point of sales. Also, it might come from the product's website, right? So, understanding the key and the structure and the table data is very important. My last point is understanding the joint performance implications. Very important, especially when you're working in a data role where you generally handle a very large data set. A well performing system is a priority for any org, and when the tables are joined, they produce even larger data. There might be some instances where you might end up creating the cross join if you are not carefully doing it, which might impact the latency and the results generated. These are few of the important things to remember. The next is the query organization. There are scenarios when you want to derive a data set from the table, then reuse it again for aggregation or maybe joining it with some other table. A very good example of this could be, let's say you are running an online store and want to find high value customers who have spent more than total spend of all the customers, right? To solve this, you would do two things. First is calculate the total spending for every individual customer, right? And then second, you'll calculate the average of those totals, and then of course you'll filter out the customers who are the high value customers. If you do it in just one query, you might end up with a very complex, non-readable, and hard to debug query. To overcome this, we have CTEs, which is the common table expressions, and the subqueries. CTs create a temporary session-wide table which can be used as a reusable table in joining and of course in other functionalities. Thus, these are very useful for optimization, maintainability, and a cleaner code. On the screen, you would see some of the important skills you should know as part of the query organization skill. Let's move forward and look at the differentiator. Till now, we have seen the basics. As the name says, these are the differentiator skills. These are actually used a lot in real time scenarios. Want to know the top performing employee or want to know the highest selling product based on some region or category, and even many more such parameters. These differentiator skills are going to help you a lot. These are required to get the results in shorter period of time with a better performance and of course a very clean code. Well, I'm talking about the window functions. Ranking, that includes row number, rank, and dense rank. Analytics, lag, lead, first value, last value, and many more. Aggregates include sum over, average over, with partition by and order by. And then you have the running totals, which has the moving averages and the percentiles. Want to track how revenue changes every year over year? Window functions let you compare a value to its previous period without writing complex joins. Need the top three products in each category? Well, you can rank within groups and filter very cleanly. Want running totals for sales or users over time? This is a natural fit. These are the real life problems, and this is something that you should be very much hands on in. What is going to put you one step ahead of all the crowd is not only how well and correctly you use the SQL functions, but how well is your query performing. In present day scenarios, a slow query can impact your dashboards, reports, and ultimately your business decisions. We talk about streaming use cases in Spark and Databricks, but what if your code doesn't fall in the same lines as the Spark engine? The system might be a failure in achieving the business outcome. To become proficient in your data roles, using your tools is not enough, but understanding about the execution is. Understand how databases process your queries, how to reduce data early by chunking out the larger data set into smaller, how to avoid expensive operations like avoiding the cross joins and the Cartesian products, and how to structure queries efficiently. Because at scale, speed is what makes your code usable. These are a few of the optimization techniques you need to be good at. Depending on the framework, there might be even more. For example, if you are using Databricks, they can be more related to Delta Table or Spark specific optimizations that you can use. Well, a quick tip here, try to demonstrate how you have used these techniques in your real time projects, or if you're a fresher in your hands on project to achieve the performance and the impact that you have created in your interviews. That is going to help you and will represent you that you are actually hands on whatever optimizations techniques that you are just talking about. Designing technique skill is going to help you move up the ladder. Till now, we have discussed around the queries, how to write them, which skills will help you make them efficient. but this skill will take you up the ladder to the senior roles. When a junior thinks about how to get the data, a senior thinks on how to create a solution which can cover all the use cases. This is done by a full depth knowledge of how your system is designed and created. These are a few which are a must know. Normalization versus denormalization, primary keys, foreign keys, and unique constants, data modeling, and of course, the slowly changing dimensions. These skills will not only help you with the system, domain, and the solution, but also help you write better and meaningful queries. In modern data solutions, SQL rarely lives alone. It is usually integrated with other tools to derive the true business value. You need orchestration to run the queries on schedule. You need flexibility to handle logic that's may not be possible in pure SQL. You need visualization to communicate results. And above all, you need a business context to ensure you are solving the right problems. These are a few tools which are not a must have, but would be a deciding factor in where you land your job. This is what was about the video. Let me know if you have any doubts, any questions, and I'll see you in the next one. Thank you for watching.